Hello class, this is Mr. Lehman. I want to talk to you today about smells, lesson 16. This is titled Electronegativity and Polarity. So polarity, going back to last lesson, we talked about polar versus nonpolar. The more polar something is, the higher the polarity is. So polarity you can think of as having difference in charges. And so if you have a lot of negative and a lot of positive charges on opposite ends of the molecule, then there's going to be high polarity. So what causes some molecules to be polar and some molecules to be nonpolar? It all has to do with this word electronegativity. And so elements on the periodic table are all looking today at a full outer shell of electrons. And so to do that, they can either gain electrons, lose electrons, or they can share electrons. And so electronegativity measures, what's going to happen when two atoms form a chemical bond, are each sort of sharing electrons with each other. Are they going to continue to share equally, or are they going to share unequally, or is one going to just steal the electron from the other one and form an ionic bond? So it has to do with their measure of electronegativity. In lesson 17, you'll have a scale which gives you a number associated with the strength or the ability of an atom to pull those electrons being shared in a bond towards itself. All right, here, so keep that word in mind. There's three types of bonds: nonpolar covalent, polar covalent, and ionic. Nonpolar covalent is, covalent means to share, nonpolar means lacks of charge, lacking charge. And so this is where two atoms share valence electrons equally. This is where two atoms form a bond and they're sharing the valence electrons equally. So let me give you an example. Hydrogen single bonds with hydrogen. So we have two atoms of hydrogen, each sharing one electron with the other. Now, to show what's really happening here, instead of drawing it as a single line, the single bonds, that single bond represents two electrons. And so what's happening here is that these electrons aren't just sitting here stationary, but instead they're constantly moving around the atoms. So maybe these electrons go around this hydrogen twice. You got to remember, they're moving super, super fast. We can't see them. They're moving so fast. We just have to assume this is what's occurring. And so maybe go around this hydrogen once, this hydrogen once. They go around this hydrogen maybe 3 times, and then they come around this hydrogen 3 times. Maybe once here, maybe twice here, once here, twice here. And so it all evens out. If we could map the journey, those electrons, those negative electrons, would spend equal time roughly around each atom. And so that means that they're sharing equally. If they're sharing equally, they're both going to stay neutral. And so they're not going to become charged. They'll be neutral. All right, another option, polar covalent. This is when two atoms share electrons, but now they're going to share them unequally. So this means one atom is more electronegative than the other atom, and the electrons are going to spend more time around the one atom than the other. So when this happens, one atom is going to be assigned a partial positive charge, the weaker, the penguin of the group, if you refer back to the comic strip in this lesson. And the more bully, the stronger atom is going to become more negative, partially negative. And so let me give you an example of this. This time hydrogen links up with chlorine. Chlorine is more electronegative. It's able to attract those electrons with more force. And so what we have here now is, let me replace the single line here with 2 dots for the 2 electrons that they're sharing. If we're going to map the journey of these electrons, hydrogen's the weaker, less electronegative one. These electrons might go around hydrogen once, and they might go around chlorine 4 times. They'll go around hydrogen maybe twice, chlorine 5 times, hydrogen twice, chlorine 3 times, hydrogen once, chlorine 5 times. You get the idea. They're spending more time over here around chlorine. Let me highlight this in red so we can see. And so chlorine, the electrons spend more time around it. Chlorine then is assigned the partially negative charge because those negative electrons are spending more time around it. So more times than not, it's negatively charged. And then hydrogen, which is having its electron pulled away from it, and it's not spending as much time around hydrogen, becomes less negative, so it actually has a partially positive charge. Our third scenario are ionic bonds. The third scenario are ionic. Ionic, one atom is so much more electronegative, so much stronger than the other atom. that it steals, it rips off an electron. One atom steals one or more electrons from another atom. So let me give you an example of what this might look like. Sodium and fluorine. Sodium and fluorine each start out for just a very, very brief split second that they're sharing electrons. But the problem is fluorine is so much stronger, so much more electronegative, that it just steals sodium's electron, and that electron goes around fluorine and it never ever returns back to sodium. And so sodium has lost the negative electron, so now sodium has a positive 1 charge. Fluorine stole an electron and now has an extra negative charge, so it's a full -1, and so this is ionic. Those are our 3 scenarios, and that's what this lesson talks all about. Hope this helped.